Hello, this video will help you to find out formula for the area of various 2D shapes and will also help you to generate formula for surface area of few 3D shapes like cone and cylinder. Let us recall square as unit of area. For measuring length we have many scales, various scales and units, and for area we use the squares of the same units as units. Yes. Suppose we have this rectangle of length 10 units and breadth 4 units. Units means it can be 10 centimeter and 4 centimeter or 10 kilometer, 4 kilometer, 10 meter, 4 meter, whatever. We're just calling it generally unit. So 10 units and 4 units. How to find out how much space is inside it? That is actually be counted by making squares inside it. How many squares can be made along the length? As it is 10 units, so 10 squares can be made of side 1 unit. If it is 10 centimeter, then 10 squares of side 1 centimeter. See, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 squares of side 1 unit, and breadth is 4. So 1, 2, 3, 4. 4 along the breadth. So in total, how many can be made? These 10 units can repeat themselves 4 times as the breadth is 4 units. So in total, 10 4 times, that means 40 squares can be made inside this rectangle. So the area of this rectangle is 40 square units. This is how we calculate the area of a square or a rectangle. Okay, so area of these two shapes is calculated by estimating the number of squares that can be made inside it. And how can we estimate that? Just by multiplying length with breadth or side with side in case of a square. So right now we have a formula for the area of two shapes, rectangle and square. That is length into breadth and side into side. Okay, now let's move ahead. Now here we have some 2D shapes. How to find their area? How to find how many squares can be made inside them? We actually cannot fit complete squares inside them as figures are not right angular. Squares and rectangle were right angular. They have right angles, no? But here parallelogram, it's not a right angular figure. If we try fixing a square inside it, we won't be able to fix it completely. So some squares will be full and some won't be. Anyways, but here the problem is how to find out its area. So here we have some tricks for these shapes. Every parallelogram will have area equal to a rectangle with the same base and same height. See, this is a rectangle with same base as the parallelogram and same height as the parallelogram. Okay, so the area is gonna be same. See, if I cut this portion and paste it here, so area of blue and green will be exactly same. Even algebraically through congruency we can prove that this green section and this blue section is equal in area. That means length into breadth, multiplying this measure of this side and this side will give us the area of green shape also and the blue shape also. What is the area of green shape? Length into breadth. And what is the area of blue shape? That is also length into breadth. That means this into this. Okay, not this into this. This into this gives us area of green and blue both. This is the hypotenuse. We will multiply this with this. The area will be more than the green and blue. That will be more than. That means this side into this side does not give us area of a parallelogram. It's always multiplied by this and this. So this is the base of parallelogram. What is this of the parallelogram? Means L into B will give us the area of parallelogram also. But what is L? What is this L for parallelogram and what is this B for parallelogram? So area of parallelogram is, this L is actually base of the parallelogram and this B is actually the corresponding height to this base. So now we got the area of parallelogram. We can estimate the number of squares inside the parallelogram by multiplying its base with its corresponding height. If this is the base, then the height falling on this base. So third, after square and rectangle, third figure is parallelogram whose formula is known, that is base into corresponding height. And how did we derive it? Through rectangle. Now again we have a triangle. How to find out its area? Here every triangle can be completed into a parallelogram. Here I made an equilateral triangle, but whatever may be the shape of the triangle, we can make a parallelogram out of it. And the triangle will always be exactly half of this parallelogram. How come? These two triangles have three sides equal. This is the side of both the triangles. This side is equals to this because opposite sides of parallelogram are equal. In the same way, this is equal. So three sides of this triangle are equals to three sides of this triangle. That means the triangles are congruent by SSS. Side congruency criteria. So as they are equal, so their area is same. That means area of this blue triangle is half of this parallelogram. What is the area of parallelogram? Base, this base of the parallelogram and the height with respect to this base. So this parallelogram is raised from this base up to this point. So this is the height. No? And so area of triangle is half of this. No? So you can say area of triangle is half of the base of the triangle and corresponding height. So area of triangle is half into base into corresponding height. So we have the formula for the fourth 2D picture, and that is triangle. And the origin is from parallelogram. Now we have a trapezium. How to find out its area? Again, either we have to resolve it into square or rectangle or parallelogram or triangle, as we know the area of these four 2D shapes only. Okay, let's divide it into a triangle. Now the area of trapezium is area of this triangle and the area of this triangle. How to find out area of this triangle? Half into base into corresponding height, means the height falling on it, on this base. Okay. So half into base into corresponding height. This is the height of the triangle. From here it's rising till here. We can treat this also as base, then this would have been gonna height. We can treat this also as base, then something else will go as a height. No? So it depends upon what all is given in the trapezium. In that ways we can split it up into the shapes. Okay. Here I purposely chose this as the base. Okay. One of the parallel side. In this triangle, this trapezium has one pair of opposite sides equal. So when I am splitting it into a triangles, I am taking a triangle with one of the parallel side as base and the second triangle with other parallel side as base. So area of this triangle is half into this and area of this triangle is half into base into this height only. Now area of trapezium is half into, I'll call it P1, first parallel side, into H. So half into P1 into H and the other is half into P2 into H. This height is same for both the triangle, distance between parallel lines. So half into P2 into H. Here is some arithmetical trick. I can say it half h is common both sides, so we can say half h p1 times half h p2 times, no? Half h p1 times half h p2 times, that means half h p1 plus p2 times. That means half into h into sum of parallel sides, or we can say area of trapezium is half into sum of parallel sides into distance between the parallel sides. Okay, half into sum of parallel sides into distance between the parallel sides. Please learn these formulas. Okay, h is the distance between the parallel sides. Now next, let's come over to rhombus. Rhombus is a figure with all sides equal. How to find out its area? Again, we have area for square, rectangle, parallelogram, triangle, trapezium. We have to split them into those. Okay, I'm just doing one of the construction. I'm just dividing them into triangle. So I'll find out area of this triangle and this triangle and then add them up. To find out the area of this triangle, I can consider any of them as the base. Okay, but here I am considering this as the base just to reach some special formulas. Okay, so this is the base, so I'll have to construct a height over it so that I can use that in my formula. Height for this triangle is this, and similarly here for this base, if I consider this as the base for this triangle, height is this. Now the area of rhombus is equals to half into base into height. That means half into x into h1. X is this and this is h1. Half into x into h2. So what is common? Half x. So we can say half x h1 times half x h2 times. That means half x h1 plus h2 times. No? Like this. Now what is x? X is one of the diagonal of the rhombus, and h1 plus h2 is the another diagonal. See, these two heights will meet somewhere. No? Will meet somewhere, and these heights will meet here only because the diagonals of a rhombus meet at 90 degrees. Okay? So this is half into h1 plus h2. h1 is the one diagonal, x is the one diagonal, and h1 plus h2 is the other diagonal. So area of rhombus is half into diagonal 1 into diagonal. Okay. See, many formulas can be generated. Here I have used this as the base and these are the heights. That's why I am able to reach this formula. If I would have chosen this as the base, I would have ended up with some other formula. But for now, what does this formula says? That if we have been given the diagonals of a rhombus, then we can find out area easily by half into diagonal 1 into diagonal 2. Okay. Area of a square is side into side. We can find out the area of square in terms of its diagonals also. No, suppose this is a square. Suppose. Okay. So this is gonna be one diagonal. Again, this diagonals of a square meet at 90 degree. So we didn't use anything like all sides equal. What did we use in this figure of rhombus? Okay, of rhombus we just used a property that h1 plus h2 will make a diagonal. No? If I wouldn't have written here rhombus, how can we say this is the area of a rhombus only? What make it the area of rhombus? We just split a quadrilateral into two triangles and then find out the area of each triangle, then added. In that way it can be area of a quadrilateral. But what did we use? We used that h1 plus h2 is a diagonal, which won't be a case in case of a normal quadrilateral. Okay, so area of a rhombus is this. So squares are also a rhombus. No, whatever are the properties possessed by rhombus, those same are possessed by square. In fact, square has some additional properties. No? So that means half into diagonal 1 into diagonal 2 is the area of square also. And in a square, diagonals are equal. So instead of half 1 into d1 into d2, we can say half into dd only. That means d square only. So area of square is half into diagonal square. This is the another formula. Depends upon in which terms do we have to find out the formula. If we have been given diagonal, we can directly substitute this formula. Anyways, next is area of circle. This is a bit trickier. We have to see, this is a 2D shape, and so far we know some of the formulas. So we have to split this figure into those shapes only. Can we split it into square, rectangle or something like that? Let's split up into a triangle. This triangle. Is it a triangle? No, it's not a triangle. It's a sector. Okay. This is called sector. So this cannot be considered as a triangle as this is an arc. So let's make it a bit smaller. Still this triangle is an arc. Let's make it a bit more smaller. Still it's an arc. If we split the triangles into circle into very small triangles, very small triangles, say infinite. So for infinite, so very small triangles, this arc here, the third side will not be an arc, will be a polygon. We may call, what is a circle? We may define circle as a polygon with infinite sides. Okay, so if we consider this as one piece of the infinity, one piece out of infinity, then it can be treated as a straight line. And if we make many triangles like this and add up the area, so we'll get the area of circle. First of all, let's write the area of this triangle. The area of this triangle is half into base 1 into half into base into corresponding height, so half into b1 into h. So another triangle like this, the area is gonna be half into b2 into h. One more triangle like this, half into b3 into h. In the same way, infinitely many triangles can be constructed. Suppose they are n triangles, so the last triangle is half into bn into h, where bn is the base of the last triangle, nth triangle. Nth can be infinite, can be 1000, can be 10,000. So last triangle's base is this. So in this way we are actually adding the areas of all the triangles. So again we can say half h b1 times, half h b2 times, half h b3 times, half h bn times. That means half h how many times? b1 plus b2 plus b3 plus bn, so on. So this is actually the area of the circle. What is h? Area of triangle. What is b1, b2, b3? These are the bases of triangle. So when we are talking about circle, normally in every circle we should not have height of the triangle and the bases of the triangle. We should have h in terms of circle and this as a dimension of circle. So what is h of circle? So this is height of, this is a triangle, and the height of triangle is actually the radius of triangle. So this is the radius of triangle. And b1 plus b2 plus b3, what are these? What is b1? This is b1, this is b2, this is b3, and in this way there are going to be many more triangles. If I add all the bases, what will I get? So this is actually gonna be equal to this full all, as we are gonna make b1 plus b2 plus bn. This is gonna give us this full boundary. That means 2 pi r. So we decided h is the radius of the circle and this is the circumference of the circle. Now this is the formula for the area of circle, and we redefined h and these in terms of something which belongs to circle. So this is half into h is r and this is 2 pi r. 2 got cancelled with 2 and r into pi r is pi r square. So this is the area of circle. This is how we divide it. Next are these shapes. Again, if we have to find out this area, we have to divide them into known shapes. This can be divided into a triangle and a trapezium, or this can also be divided into 3 triangles. Depends upon what all measures are given of this figure. If we have to find out its area, some measures must be given. Depending on those measures, we can divide this. shape into various shapes whose formulas are known. Formula for area is known. Here we can divide it like this, and this can be divided into triangle, and so many triangles can be made. By adding the area we can find out the area of this 2D shape. So in case of 2D shape, we can split the shape into known figures. Okay, and the known figures were these only, which I explained you so far. Okay, now let's move towards the 3D shapes. Okay, this is the rectangle. Now this rectangle can be folded along its length or breadth. Okay, I'm folding it along its length. It can be folded to make a cylinder. What does this mean? This full area, this became the curved surface area. This surface became actually the surface of the cylinder. No? So this area around this cylinder is actually equals to area of this rectangle, no? Because this is made out of it. Okay, and what's the area of this rectangle? L into B. What is L? This. No? And what is B? This. Okay, that means if I multiply this with this, I'll get the area of this cylinder also. Okay, so the area of the cylinder is the area of the surface of the cylinder. This surface of the cylinder is L into B. But what is L and B for cylinder? We need to, yes, these two gives us the area of the cylinder, but we need to redefine these variables so that they become some part of the cylinder. So what is this? This is the length along which we are rolling it, and this length actually becomes the height of the cylinder. No? And so this is the height of the cylinder. And what is B? Just see what happens to this B when we are rolling it up. This B actually going this way, and when we join it, it gets joined to this. So it is actually like this. No? So this B actually became the circumference of the face of circular face of the cylinder. That means 2 pi. So now we can say surface area of cylinder. In fact, we can say curved surface area, means area of the curved surface. This surface of the cylinder is actually equals to L into B. That means H into 2 pi r. No, this is H, green is H, and B is H into 2 pi r. That means 2 pi r H. And if we have to find a total surface area, as cylinder has two more faces, top and bottom, no, so, and both are circular, so total surface area will be 2 pi r H plus 2 pi r square. And at times it is written in some other form by taking 2 pi r common. It is common in both the terms. Here we have 2 pi r, and the second term here we have 2 pi r. So 2 pi r, here we will be left with H, and here 1 r. So 2 pi r into H plus r. Okay, so this is the curved surface area, total surface area of cylinder. Now let's move towards the another 3D shape. It's made out of the circle. It is cone. Area of a circle is pi r square. If we can make out a cone out of it, then the surface area of the cone will also be pi r square. But first we have to confirm whether a cone can be made out of it or not. Okay, so I'm just trying making a cone out of it. If I actually have to make a cone out of it, the only way out is this. Here I have a cone. So this area of cone is not equals to circle because some portion is not being used. Basically, we cannot make a cone out of a circle. If we have to make a cone, we need a sector rather than a circle. Sector, some piece is to be cut off.
Okay, so this piece is called sector. Okay, we can cut out this one piece out of it and then we can make a cone out of it. Now we have the sector of the circle. This can be easily made cone without overlapping. Okay, so this is our cone, and now the surface area of the cone is actually equals to area of this sector.
So a cone cannot be made with a circle. We actually need a sector for it. So we need to divide it from here and here and just take it off. Now we just have to join this to this and then we'll get a cone. Okay. Now as this area, this curved surface of the cone is made out of the sector, so area of this sector is actually equals to the area of curved surface area of this cone. No? So how to find out this area? Area of this sector, again exactly like circle, area of the sector, we'll divide this into small triangles and we'll find out the area of all those triangles. No? So that is, first triangle is half into B1 into H1, where B1 is this and H is this. Okay, so half into B1 into H1, then we have half into B2 into H2, not H2, H is same for all the triangles, then half into B3 into H, and the same way suppose they are n, they are infinitely many, because only then this can be treated as the side and this as the triangle, and only then we can apply half into base into corresponding height. So on we have the nth triangle and this is the area. So this is the area of all the triangles. Again, half H is B1 plus B2 plus B3 this. So this formula will give us the area of the sector, and so is the area of curved surface of the cone. But what is H for the cone? We need to redefine them in terms of the cone. Okay, this is the formula for the cone. What will we say? What is B1, B2, B3 here? Okay, so let's redefine these variables for this cone. What is this H for the cone? So we have to find curved surface area of the cone. This H of the sector is this. This is actually the radius of the sector, but we're not interested in this. We just want to see what does this H becomes of this. So this H, when we join this to this H of the sector actually becomes the slant height of the cone. And slant height of the cone has the conventional variable this. We call slant height as L. Okay, so this H becomes the, on joining this H, the height of the triangle is this only. This is actually the L of the cone. And what does this B1 plus B2 becomes? Let's see what is B1 and B2. So this is your B1, this is your B2, then B3, then B4, then B5, B6, B7, B8 and so on till here. So this full, what does this becomes? This actually becomes this. When we'll make this a cone, this will get joined with this, and so this red line will get joined, this dotted line will get joined, and it will actually becomes the circumference of the base face of the cone. No? So we can say this H can be replaced by L, and this B1 plus B2 can again be replaced by 2 pi r. but 2 pi r is not the circumference of the sector, it's actually the circumference of the base circle. When we'll join it, we'll get a circle. So A surface area is curved surface half into L into 2 pi r, where r is the radius of the base. Okay, by cancelling 2 with 2, we'll get the formula, which is pi rl. So curved surface area of the cone is pi rl, where r is the radius of the base and L is the slant height. Okay, so whenever you have to calculate the curved surface area of the cone, you can use this formula, value of pi, radius of the base circle, and L slant height of the cone. And what is the total surface area? For the total surface area of the cone, we have to add the area of the one more face. What's that face? Here is one more face here. Okay. So, and this face is circular. So total surface area of cone is pi rl plus pi r square, which is also written as pi r into L plus r. Okay. So this was all about areas. Okay. Please learn these formulas and do learn them from their basis, from their origin. Okay, and that ways you'll be able to recall every variable, what is L, what is R, and you find yourself well equipped for the application level questions. Okay, that's all for this video. Thank you.